Let's start from the beginning and explain why this is called the circle of fifths. At the 12 o'clock position on the outer circle, you have C. This is because the key of C contains no sharps or flats. Now you could interpret this as the note C, the chord C, or the key of C, but for now this doesn't matter. As we travel clockwise, we go up in fifths. So for example, C to G is the distance of a fifth. I do have a lesson on intervals if you're not sure what a fifth is, but essentially if you were to count up 5 notes in the major scale, you would end up on the 5th degree of the scale. So that would be C, D, E, F, and G being the 5th degree in the scale. Or a quick shortcut for guitar players, simply play a power chord. Now if we continue clockwise around the circle, you will continue to travel in fifths. So G to D is a fifth, D to A is a fifth, A to E, E to B, and so on. It's also worth noting that if you travelled counterclockwise around the circle, you would be moving in fourths, as the distance between a C and an F, for example, would be a fourth. The distance between an F and a B flat would also be a fourth, and so on counterclockwise around the circle. For this reason, you might also see the circle of fifths referred to as the circle of fourths. You will notice that at the 6 o'clock position on the circle of fifths, we have what's known as an enharmonic equivalent. For example, F sharp is 1/2 step higher than F, so we could call it F sharp. And because this same note is 1/2 step lower than G, we could also call it G flat. We will also apply this to the keys either side of the 6 o'clock position. So D flat could also be called C sharp, and B, which could also be called C flat. This will all make sense soon. This leads us to the order of sharps and flats. As you go clockwise around the circle of fifths, each key will pick up sharps. For example, starting from the 12 o'clock position, we have the key of C, which, as previously mentioned, has no sharps or flats in its key signature. Moving clockwise, we arrive at the key of G, which has 1 sharp. D has 2 sharps, A has 3, E has 4, B has 5, F sharp has 6, and finally the key of C sharp, which has 7 sharps. As you go counterclockwise around the circle of fifths, you will pick up flats. For example, the key of C, once again, has no sharps or flats. The key of F has 1 flat, B flat has 2, E flat has 3, A flat has 4, D flat has 5, G flat has 6, and finally the key of C flat, which has 7 flats in total. So we have our sharp keys clockwise and our flat keys counterclockwise. It's important to note that 7 is the maximum amount of sharps or flats allowed in a key signature, but we'll discuss this later. To know which sharps are in each key is easy. Let's go back to the key of G, which has 1 sharp. To figure out what this is, you could simply jump over the previous key going anti-clockwise to reveal F. So the key of G has 1 sharp, this being F sharp. If you did this once more, but for the key of D, which has 2 sharps, you would jump over G and back to F, and this time includes C. So the key of D has 2 sharps, F sharp and C sharp, and once more, but this time in the key of A, which has 3 sharps. Jumping over the previous key, being D, would now reveal F, C, and G, being the 3 sharps in the key of A, so F sharp, C sharp, and G sharp. You would now simply continue to do this until you get to the key of C sharp, which would contain the maximum amount of sharps allowed in a key. This method works and is important to understand, but there is a quicker way, this being the order of sharps. If you laid the order of sharps out starting from F, you would end up with F, C, G, D, A, E, B, which you could memorize using the common mnemonic, fast cars go dangerously around every bend. So imagine that you needed to know what sharps were in the key of E, for example. You could say, fast cars go dangerously. So F sharp, C sharp, G sharp, and D sharp. And remember not to include the key that falls directly anti-clockwise or to the left of the intended key. And now we need a way to work out the flats in a key, which brings us to the order of flats. And thankfully the order of flats is easy. Simply reverse the order of sharps. This leaves us with B, E, A, D, G, C, F, which you could commit to memory by saying bead, go car fast. And it's also important to note that no notes are skipped this time. Simply pick up the flats in the order that they occur. For example, the key of F has 1 flat, this being B flat, as this is the first in the order of flats. The key of B flat has 2 flats, this time being B flat and E flat. The key of E flat has 3 flats, which are B flat, E flat, and A flat. And you would simply continue anti-clockwise around the circle of fifths, picking up flats until you arrive at C flat, which contains, again, the maximum amount of 7 flats. You should commit the order of sharps and flats to memory either by mnemonics or just cold memorization, which I've always personally preferred. Hopefully it's becoming clearer as to why only the bottom 3 key signatures are written as enharmonic equivalents, while the other keys which potentially could be are not. But let's focus on this in more detail to really set this in stone. If we focus on the 7 sharp keys, and now the 7 flat keys, you will notice that they overlap exactly where the 3 enharmonic equivalent keys are located, giving us different options when naming these keys. So you could write a song in a key of D flat or C sharp, which would essentially be the same thing. This would also apply to the keys of G flat and F sharp, or C flat and B. However, you will find that the choice is mostly always dictated by which key has fewer accidentals. In this case, this means sharps and flats. So in the case of C sharp, which has 7 sharps, versus D flat with 5 flats, the key of D flat would be preferred. And in the case of B with 5 sharps and C flat with 7 flats, the key of B would be preferred. And finally, in the case of G flat versus F sharp, which both have an equal amount of accidentals, this being 6 sharps and 6 flats, either would be fine, and the choice might come simply down to what group of instruments you're writing for. For example, a brass section might prefer seeing flat keys because that's what they're used to. It just depends. Now notice how the rest of the keys don't have enharmonic equivalents, such as A flat for example. Couldn't we call this G sharp? They're the same, surely. To explain this, we simply need to lay out the notes of each respective major scale, so both the keys of A flat major and G sharp major. First, let's name the notes of the A flat major scale, this being A flat, B flat, C, D flat, E flat, F, and G, before returning back to the A flat again. So all of these make sense and would be easy to both read, whether you were referring to these as notes or chords. However, now let's take a look at the enharmonic equivalent of the key of A flat, which would be the key of G sharp. And it's important to note that every major scale can only have one note of each note name, and they appear in alphabetical order, which will become clear in the following example. This time, in the key of G sharp, you would have G sharp, A sharp, B sharp, C sharp, D sharp, E sharp, and the next note is where the problem lies. As stated before, we can only have one of each note name in the major scale. So we already have A, B, C, D, E, and G, so the next note has to be an F of some kind. And in this case, to keep to the rule, we would have to name this F double sharp. So if you try to name any of these keys with their enharmonic equivalents, you would find that they would all contain either double sharps or double flats, and placing these in the key signature would simply make the music generally impractical to read. And for this reason in music, we refer to these keys as theoretical keys. So in theory, could you write a song in G sharp major? Yes, but why would you? So hopefully that clears up any confusion you may have had on this subject. So that's the outer circle of the circle of fifths taken care of, but what about the inner circle? While the outer circle shows the major keys, the inner circle shows the minor keys. So you could say that the circle of fifths is sad on the inside, much like me when I find that the like button still hasn't been clicked. First, let's focus on the C to A minor relationship. The reason A minor is directly below C is that it's the relative minor of C. This means that it shares the same key signature and has the same amount of sharps and flats, in this case 0. To illustrate this further, we can lay out the notes of a C major scale, being C, D, E, F, G, A, B, and the notes of an A minor scale, A, B, C, D, E, F, G, and you will notice that they are the same. So the key of C major has no sharps or flats, and neither does the key of A minor. Now this works both ways, so you could refer to the key of C as being the relative major of A minor. The relative minor of any key can be found by climbing to the 6th note in the major scale. So in the key of C, for example, this would be A. Or if you would like a really quick way of visualizing this on guitar, then play the relative major with your pinky finger, and then count backwards fret by fret until you end up on your first finger. This note will be the relative minor. This relative minor relationship continues around the circle of fifths. So E minor is the relative minor of G, B minor is the relative minor of D, and so on. These also move in fifths clockwise and fourths counterclockwise, just like the outer circle. The enharmonic rules that we apply to the outer circle also apply to the inner circle. So the key of B flat minor could be called also the key of A sharp minor. The key of E flat minor could be called D sharp minor, and the key of G sharp minor could be called A flat minor. but once again you would typically stick to the key that has fewer sharps and flats. And now let's focus on the more practical side of the circle of fifths so that you can use this to actually make music. And we'll do this by now viewing the circle of fifths not just as key centers, but also chords. Every key has 7 chords, one for every note in the scale. So in the key of C, this would give us C major, D minor, E minor, F, G, A minor, and B diminished. And if you assign numbers to these, you'll notice that the 1, 4, and 5 chords are major, while the 2, 3, and 6 chords are minor, leaving the 7 which is diminished. This effectively tells you which chords sound good together and allows you to easily write your own compositions. And the circle of fifths has a very good way of displaying this. As you can see, the key of C is placed in the center and will represent the key center. And not only this, but it also represents the C chord being the first chord in the key. Counterclockwise is the 4 chord F, and clockwise is the 5 chord G. The inner circle now shows the 3 minor chords in the key of C. This being the 6th chord, which is also the relative minor, A minor, the 2 chord D minor, and the 3 chord E minor. The diminished chord is not included, but this is easy to find as it's built on the leading tone, or in other words, 1 half step or fret below the 1 chord. So in this case, B being B diminished. This acts as a great visual aid to figure out what chords belong to a key and their relationship to each other. So for example, if you wanted to find the 1, 4, 5 chords in the key of A, then you would find A on the outer circle, and that's the 1 chord. 1 space counterclockwise is the 4 chord, which is D, and 1 space clockwise is the 5 chord, which is E. And as you move around the circle of fifths, this can be used to very quickly work out the chords in every other key. I also want to mention that for writing songs in a minor key, you would simply use the same chords as the relative major, as they contain the same chords. Just be sure to place more emphasis on the A minor chord as being the center of your chord progression, rather than the C. Here is another way of looking at the circle of fifths to find the chords in a key. Let's say we're back in the key of C. What you need to do now is go 1 place counterclockwise to the F, and then count 7 spaces clockwise. These are the same chords that belong in the key of C. The first 3 are the major chords, 1, 4, and 5. The next 3 are the minor chords, 2, 6, and 3. And the last one is our diminished chord, in this case B diminished. Although this is yet another way of displaying the chords in a key, I would say the first method is slightly neater and easier to look at. Now, playing purely within a major or minor key can be limiting, as you only have access to 7 chords, and no matter what you do with these chords, it's unlikely that you'll come up with anything that stands out as unique or unexpected. Luckily enough, this is an easy fix. You don't always need to limit yourself to simply playing the chords within a key. Instead, you can borrow chords from other keys. And the easiest example of this would be borrowing chords from the parallel minor, which will give you much more interesting chord flavors and combinations. What is the parallel minor? Well, simply put, if you were in a key of G major, then the parallel minor would be G minor. We can go around to the key of G minor and choose from any one of these chords to use in a G major progression. For example, a very common choice is to use the 4 minor chord. So in the key of G major, the 4 chord is C major. And if we look in the key of G minor, you will find a C minor chord. So within the context of a G major key, we would call this a 4 minor chord. You can experiment with as many options as you like from the parallel minor here to find a chord progression that works for you. And I want to add a quick note about improvising over these progressions. If your chord progression is built diatonically, meaning entirely from chords within the key, then choose the major scale that they're built from. So in the case of a G major chord progression, this would mean using the G major scale over all these chords. However, once you introduce a borrowed chord from another key, you will also have to temporarily use the scale from the key you borrowed from to improvise over that borrowed chord. So in the case of borrowing from the parallel minor, this would mean using the G minor scale over any of the borrowed chords that you chose to use in a progression. The circle of fifths also gives you yet another tool for crafting songs or chord progressions, and this is being able to see which keys are more related than others. And why would you want to know this? Well, this allows you to smoothly change keys. For example, let's say we had a chord progression in a key of D major, and we wanted to modulate, or in other words, change key, then we could simply look at the keys either side of D on the circle of fifths, these being the keys of G or A major. At a simple glance, you should be able to see that the key of D shares 4 chords with the key of A, and also 4 chords with the key of G. You can describe these chords as pivot chords. Using these pivot chords will allow you to smoothly slip into the new key center without a jarring or sudden change, as your ear won't detect the key change until you've settled into the new key. This of course also tells you that the further you stray from the original key, the harder it might be to change key effectively. For example, a key change from C to F sharp might be more challenging, as they have much less in common. This isn't to say that other ways of changing keys can't be used, and many other methods are highly effective, but I'll save that for another lesson. Hopefully this lesson has helped you understand the circle of fifths and its many uses. Feel free to leave your thoughts or questions down in the comments, and if you want to support the channel, check out my Circle of Fifths merch, link in the description. Thanks for watching once again, and I'll see you in the next one.